Some more applications on the normal distribution. Here is an exercise. Given that the IQ scores are normally distributed with a mean of 110 and a standard deviation of 25. First question. What's the probability that a randomly selected person has an IQ less than 100? Here we need to find the probability of X less than 100. Why I didn't put Z here? Because he says there is a mean and a standard deviation. Every time the mean is not 0 and standard deviation is not 1, you have to put X. So we need a probability of X less than 100. Let me show you how to do that using static range. Okay, so what was the mean? Just 1 second. Mean was 110 and standard deviation is 25. We'll go back to static range. 110, standard deviation is 25, and we need probability of X less than 100. It's 0.3446. Okay, let's go back. That means 34.46% of individuals in this age group have an IQ score less than 100. And I put a screenshot in how we use StatCrunch for this one. Okay, next question. What's the probability of an IQ score is less than 100, more than 118? Okay, let's take you back to StatCrunch. Same mean and standard deviation, more than, very easy, look, watch, 118, compute, which is 0.3745. So that means 37.45% of individuals have an IQ score of more than 118. I could have reworded this question and said what percent of IQ scores is more than 118. Whatever the question, guys, whether it is a percent or if I say probability, if I say area, it's the same thing. It's a probability question. Okay, let's go back. Next question. What percent of IQ scores is between 90 and 115? In other words, what's the probability of an individual scores between had an IQ score between 90 and 115? Let's go back to StatCrunch. Okay, between, you have to click right here. Oh, sorry. Okay, and now put 90 first, 115 next, and here it is. 0.3674. 36.74% of individuals who take the IQ test have a score between 90 and 115. Next question. Now, he's given you the probability and he wants the IQ score. So we're working backwards now. What IQ score would place someone in the top 10% of all IQ scores? Here's how we do it. I put the explanation right there, but I'm just going to show you how to do it. Okay. We go back to standard right here. Top 10%. That means the area to the right is 10%, 0.10. And you have to make sure this is a greater than, which is a greater than, which is good. And now we can get the IQ score. The IQ score is 142. So anyone who take the IQ test and score 142 or more will be placed in the top 10% of all IQ scores. Okay? I put 142.04, but you can simply put 142. Okay, what IQ score represents the middle 70% of all IQ scores? Let me show you how to do that. The middle 70%. What do we mean by the middle 70%? I'm going to show you using StatCrunch. Okay. Okay, for the middle, you have to go between and put an area of 70% right here. And hit compute, and you're going to see that. You see this red shaded area is 70% of the entire curve. He wants the value right here, and he wants the value right there. So one is going to be below the mean, and another one is going to be above the mean. This is the mean right here, 110. Okay, so we need this value and that value, and they're already given to you guys. The first one is 84, and the second one is 136. So that's how you work with the middle if he asks you a question like that. The values that represent the middle 70% of the scores are 84 and 136. What about if I give you this one on the test and said what value represent the middle 85%? So watch, guys. You just go and change this one to 85. That's it. And you see, once you enter something in the probability box, the boxes that would represent the x values become empty, blank, and then you just hit compute and you're gonna get the values. So this is for the middle 85%. Okay. Okay, now some basic questions that involve z-scores, not x values. What is the z-score for which the area to its left is 0.35? So let me take you to StatCrunch. Okay, so since we're working with z-scores, we're going to go back to 0 and 1. And just go to standard again. Area to the left, guys, means less than. And he gives you the area, which I need to look again. What was it? Area is 0.35. So just go back. So to the left, you have to use a less than, and it's going to give me the z-score. The z-score is negative 0.39. That is the z-score. Let's see the next question. Find the z-score for which the area to its right is 0.57. Okay, now right, we need to change this to a greater than, and I need to change that one to 0.57, and we're going to get the z-score, which is 0.18. Usually z-scores are rounded to 2 decimal places. Next question. Oh, negative 0.18. I'm sorry, I just made a mistake here. To the right. I'm sorry. So it should have been to greater than. Oops. And 0.57. Let me just look at all right, and now it's negative 0.18. I thought I changed this sign to greater than, but it didn't change. All right, let's see what's next. All right, find z, and there's a sub-index 0.44. When you see something like that, that means the area to the right of z is 0.44. So here's how we do it. Just go to StatCrunch. This is a greater, which is good, and just put 0.44 here. Compute, it's going to give you the answer, which is 0.15. You can see, guys, the screenshot that I provided you with right here. Okay, next question. What's the probability of z less than negative 1.35? He doesn't need to give you a mean and standard deviation, guys, here, because once we talk about z, it's 0 and 1. So just go that. Now it's a probability again. He doesn't want z-score. He wants the probabilities. So back to normal. Standard, okay. 0, 1, less than negative 1.35. That's it. You could use the table to find this one, but StatCrunch is good too. So the answer is 0.0885. That's the answer. Next question. That's it. Let me just add a few more questions. What about if we want to find the probability of z less than, greater than negative 1.35? Let me show you. So just make it greater, negative 1.25. Oh, that's why it's not allowing me sometimes to pick it up. Okay. And look, this is negative 1.35. Greater, it's an area shaded to the right, and 0.911. Let's say I want to find the area of z between negative 1 and 1.3. Okay, just go to between, put a negative 1 here, and I said 1.3, and just hit enter, and here's the area. Look, This is -1 here, and this is the 1.3. Let's say I want to find the area of Z greater than 2.1. Just go back to standard, greater than, and then just put 2.1. Hit compute, and here's the area, which is 0.017. Any area that you get less than 5% is considered unusual. Anything that is 5% or more is usual. Okay, so this is a review of the normal probability distribution chapter.